everyone, my name is Rakia Tapia and I'm a blockchain and Web3 solution architect here at AWS. The focus of today's video is to talk about various access methods to connect to Amazon Managed Blockchain Service. I will start by giving an overview of Amazon Managed Blockchain Service. Then I will briefly talk about different security methods to access AWS resources in general. I will spend a considerable amount of time in talking about Signature 4 and token-based access method, which is used to connect to Amazon Managed Blockchain Service. And then finally, I will conclude this video by doing a comparison of Signature 4 with token-based access method. Amazon Managed Blockchain Service is a fully managed service that makes it easy to create and manage blockchain network. Currently, we support Hyperledger Fabric for enterprise blockchain network and Ethereum for public blockchain network. Amazon Managed Blockchain Service allow you to deploy a dedicated full Ethereum node that can be used to query and send transaction to blockchain network. Beside supporting Ethereum mainnet, we also support many popular testnets like Goerli. Let's spend some time looking at security and how AWS resources are accessed. Identity and Access Management Service, in short IAM, is a key security-related service in AWS. In IAM, we define users, group, role, and policies to give or deny access to AWS resources. Access rule defined in policies can be attached to users, group, and roles to give appropriate access to the AWS resources. Federated users can assume role with appropriate policies attached to the role to give access to the AWS resources. A common way to access AWS resources is via CLI or SDK. Now, there are SDK available for many common programming languages like Java, JavaScript, .NET, Go, Python. And both the CLI and SDK uses access ID and secret access key combination to gain access to the AWS resources. Access ID and secret access key combination is associated with an IAM user, and thus when a CLI or the SDK uses the combination of access ID and secret key access key, it gains access to all those AWS resources which are permitted for that particular AWS user. There are two ways to store the access ID secret key combination. One is via the credential file and the other via the environmental variables. So when you run the command AWS space configure, the command asks you for two pieces of information, which is access ID and secret access key, and then it stores that in a credential file, which usually is in the profile directory of the user. The other way to store these two pieces of information is in the environmental variable, AWS access key ID and AWS secret access key. And both the CLI and the SDK, by default, they know to look into these two areas to gain access to the ID and the secret key. Now, both the CLI and the SDK, it uses access ID and secret key, and it signs the request which you're sending to AWS resources on your behalf. So as long as you have configured the access ID and secret key, you really don't need to do anything from signing that request to the AWS resource. But what about if you don't want to use CLI, or maybe you are writing your code in a programming language for which there is no SDK available? Then how do you call the different AWS resources, the API for different AWS resources? For that particular scenario, AWS do provide you with another mechanism of gaining access to the AWS resources. And that procedure or that access method is called Signature v4 access method. In short, SIG v4. In this video, we will spend a considerable amount of time looking at Signature v4 method because it is one of the ways to access Ethereum node on Amazon Managed Blockchain Service. When you want to send JSON RPC transaction to Ethereum node running on Amazon Managed Blockchain, you need to authenticate with the Managed Blockchain Service. One way of gaining this access is via signature v4, and the other way is via token-based access, or TBA for short. Now let's look at signature v4 more closely. The detailed steps of generating a security key using SigV4 is documented at this URL. So let's look into these detailed steps to see how signature 4 is calculated. The first step in the creation of signature 4 is to calculate what we call canonical request. There are a few parameters which this request will you need to provide it. Some of them are very obvious, like HTTP method. That would be either the get or post of the API method which you will be calling. Then there are certain parameters which are related to the request URL, the URI, the URI, the query string which is part of your request, and also the payload of your request. You will take the hash value of the payload. This is an example of the different parameters which are provided to calculate the canonical request. Once you have that request, you will take the hash of that request and then concatenate with some other additional parameters like algorithm, request date time, and credential scope. After the step 3, you will calculate the signature. Now the signature is a series of hashes where each hash step takes a value which was calculated in the step before it. Again, here there is a detailed example of what these different hashes will calculate. So for instance, the K region is taking the date parameter or K date hash which was computed in the step above it, and then concatenating it with the region which where your AWS resource exists. And finally, the last step would be to get the calculated signature from the first 4 steps and associate that signature with one of the authorization header of the request you're trying to send to the AWS service. As you can see from these steps, creating signature 4 is quite a cumbersome task. And you really need a very good understanding of cryptography to be able to calculate this signature 4. Fortunately, there are resources available via AWS SDK which helps in generating the signature v4. And the next step, we will look into one of such coding examples to see how AWS SDK can be utilized to calculate signature v4. Now I'm going to walk you through a complete example of showing you how signature v4 will be calculated and how we can use popular tools like Truffle to make a connection to the Ethereum node on the Amazon Managed Blockchain Service. Now, before I show you the code, I just want you to point out that the code is using JavaScript SDK version 3.0, and the modules in that JavaScript SDK which we will be using, it is signature v4, signature dash v4. So the in order for you to use this, you have to do npm install, and this is the full name of the npm package which you will be using. So I've prepared some sample code to show the different access method to Amazon Managed Blockchain Service. Now there are few key concepts which I want you to understand. The first thing is the contract provider. So the way this code works, it acquires the provider from Web3.js API and uses that provider to make connection to the Goerli network on Amazon Managed Blockchain, as well as the mainnet network on using the Amazon Managed Blockchain Service. Now, it will, depending on the parameter I set in this particular file, So right now the parameter I've set is AMB-TBA. If the parameter is AMB-TBA, it will use the token-based method of connecting to Amazon Managed Blockchain. And if the parameter is AMB SIG4, it will use the signature 4. If none of these are provided, then it will assume that I want to connect to a local development network running Ganache, and that's what it will use. The second important file to understand is this network connect.js file. This file, what it does, actually, when I will run the application, I will be running this code in this file, and all it does, it gets the Web3 provider, Web3 JS network provider for the blockchain network, and then it will query the network for its network ID, as well as it will query the network for a particular address, for a particular balance for a particular address. And I do have some Ether associated with this address in Goerli network, but I don't have anything associated with this address in the mainnet network. The third important file, and this is the file which I will be going in a lot more details later in this video, is the AWS HTTP SIG v4. The way the signature v4 works, that it will extend the default HTTP provider of the Web3.js so that it can inject the appropriate authentication headers required to make connection to the AMB network. And we'll go into this this particular file in more details. And the last file which I would like you to have a look at is the environment. It's a bash script which just sets few environmental variables. These environmental variables, most of them, as you can see, they are retrieving some of the environmental variables from Secret Manager, and there are some environmental variable which is holding the URL pointing to the AMB node. And we'll be going through these file in more detail as we progress in the video. So now let's dive deep into how Signature v4 is implemented using JavaScript SDK. The first thing to understand is we are using Web3.js library to make connection to the blockchain network. The same Web3.js libraries are used whether you're making a connection to Ganache network or a network, Ethereum network via AMB, or even you can use it to make connection to a Ethereum network via, let's say, Infura or Alchemy. So what we do, we use the Web3.js HTTP provider, which takes a URL and makes connection to the blockchain network via that URL, and we extend that HTTP provider. And the reason we do it so that we can inject the authorization headers into the HTTP requests, which are required to make authentication to the Amazon Managed Blockchain. Now, HTTP provider has a function called send, which we will override to make sure that we inject our authorization headers into the HTTP request, which Web3.js will make to connect to the blockchain network. The most important aspect of this code, which you need to understand when it comes to signature 4, is this function, is this class signature v4, which is defined in the AWS JavaScript SDK. The npm package where this is defined is AWS SDK / signature v4. This class takes few parameters. One of the parameters it takes is, of course, the name of the service to which it wants to create a signature for request for. It also requires you to provide the region where you want to make that connection. The other two parameters it requires, requires the credential which gives the signature v4 access to the access ID and the secret key. Now, these are the same main values or security values which the CLI and SDK also uses. And the last thing this signature v4 constructor requires is you need to provide what kind of hashing function you will be using to create this signature v4. Here we are saying we will be using the SHA-256, and again we are using AWS provided library to provide that hashing function. The signature v4, it takes these 4 parameters, it generates a object and using that object we can now sign the HTTP request. Now the signature v4 class provide many methods, many sign methods. Each of them takes separate or different type of parameters. Some take strings, some take HTTP request. And here that's exactly what we are doing. We are signing the signature, we are making signature v4 class sign our HTTP request by combining the credential, the region, the service, as well as some of the other authorization values which you saw in the when we went through the manual steps of creating the signature v4. And now once we call this sign, we have our authorization headers and the date header ready for it to be injected into the HTTP provider request which Web3.js will send to the Amazon managed blockchain network. So that's exactly what this is doing. It is retrieving those 2 headers from a signed request which got generated through the signature v4, and then we use these 2 headers, assign it to the request object which will be sent to the Amazon managed blockchain service. And that's how the signature v4 required headers are injected into the request, HTTP request, so that authorization to AMB can happen. Since now you have a good understanding of signature v4 access method, let's talk about token-based access method. Token-based access or billing token allow authentication token to be passed as query string to the Ethereum node via its URL. You create a billing token at an account level, which means the same billing token can be used from multiple nodes, both mainnet and testnet nodes. It is a lot convenient than signature v4 access because it does not require you to write any kind of custom code, but it might not be suitable for every use case. Billing token need to be safeguarded because if you lose the billing token, or if any malicious user get access to billing token, they get access to your entire Ethereum node. So now let's talk about how billing tokens are created. There are actually 2 ways to create billing token: via the CLI and via the Amazon Managed Blockchain Council. So today I'm going to show you how to create a billing token via the Amazon Managed Blockchain Council. So when you are on the Amazon Managed Blockchain Council, if you look on the left side navigation, you'll see token-based access link. Click on it. And if you have already any token access created, you will see them listed here. To create a new one, click on the new button and a new billing token is created for you. It's as easy as that. In order for you to get the actual token which needs to be passed as a query string, you will click on the link of the accessor ID and your token is shown here. You can click, you can copy it and maybe bring it to a text editor. Now let's understand the difference between the 2 types of URL. So here I have the URL associated with signature 4, which is a URL which shows that it is this first part of the URL is the node ID of my Ethereum node, and then the second part is the standard, AWS service name. So here it is ethereum.manageblockchain. The region name and the Amazon AWS.com. In comparison to this URL, when you look at the billing token URL, the first thing you will notice that there is an additional character, this character, which is between the node ID and ethereum.manageblockchain. So insertion of this character T is important. And of course, the second part of the URL, which is different, is this query string billing token. Now, the token which you had acquired from the console needs to be appended here as a query string, and this entire URL will be then passed to access the Amazon Managed Blockchain service. Now, one thing I want to mention here is that you should never store the billing token or the complete URL in as a config file in close to your code, especially if you are deploying your or committing your code to a GitHub repository, because it will be extremely bad practice to allow the billing token or the URL, the complete URL, to be exposed in the Git repository. The way I'm doing it here is I'm actually also storing the entire billing token in the secret manager, and just like how I get the secret access ID and access key ID from the secret manager for signature 4, I do the same thing for billing token also. I get the value from the secret manager and then use that value to get my URL, so that for accessing the AMB node. So now what I would like to do is do a quick demo of both using the billing token as well as the signature v4 to show how the access to AMB happens. So as I had already mentioned, that this contract provider JS file controls which access method we will use. The parameter right now assigned to the network connect is AMB-SIG4, and therefore it's going to be using the extended HTTP provider which we have created, and it will be using signature v4. So let's run this code. Now I want to mention here that my signature v4 URL is pointing to the mainnet, and my token-based access is pointing to the Goerli network, both via the Amazon Managed Blockchain service. So in order for me to make sure that I use signature v4, I have to set the network connect variable in the connect provider file to the whatever access method I want to use. So first I'm going to be using the SIG v4 method to connect to the mainnet. And when I run the code in the network connect.js, it will retrieve the network ID as well as any balance associated with this account. So let's run the code. I'm running Node with the network connect.js. And as you can see that it returned the network ID of 1, which is the mainnet, Ethereum mainnet address. And of course, I have no balance associated with this account, so the balance it returned is 0. Now let's change the variable and make it AMB-TBA so that it can use the billing token. And this is going to be pointing to the Goerli network. And there you go. The network ID return is 5, and of course I do have some Ether balance associated with this account. Now let's talk about some key differences between signature 4 and token-based access. Token-based access is convenient to use, as you've already seen that it does not require any kind of custom coding. Different type of access cannot be specified using TBA. What it means that once you create a billing token, that URL have full access to the Ethereum node, and that access cannot be restricted in any way. Signature v4, on the other hand, uses the same security mechanism used in many of the AWS services and thus is a proven security access method. Access ID and secret key used in the SIG v4 can be associated with a user with least privilege access. Make sure you understand the pros and cons of both the access method before you decide to go with one or the other. Thank you very much for watching this video. Please leave your comments and feedback below. Thank you.